Hello, I'm Matt Hatton, founding partner at Transformer Insights. I'm conducting some guest interviews for the Things Conference, and I'm delighted to say I've got with me Tuofu Liu from Semtech. Tuofu, welcome.
Oh, thanks, Matt. Glad to be here.
Excellent. If you could just say a few words of introduction to yourself, who you are, what you do. I mean, most of the people who are attending the event, I'm sure, will be familiar with Semtech, but maybe there's a few who aren't. So a couple of words about that, I think, would be a useful thing as well.
Yeah, I'm Tuofu. I joined Semtech in June last year. So I'm a product marketing manager and responsible for LoRa products.
Okay, very good. And we're here to talk about specifically satellite, the use of satellite, or the support for long-range frequency hopping spread spectrum, which was announced by the LoRa Alliance back in November. Can you tell me a little bit about long-range FHSS, what the difference is between that and LoRa, and why it's important for all the people who are tuned in?
Yeah, sure. So long-range FHSS is a different modulation technology compared to LoRa. It is a frequency hopping spread spectrum. So FHSS stands for frequency hopping spread spectrum. So basically, when a LoRa end node or LoRa transceiver device sends a packet, that packet will be broken into different pieces. Each pieces are sent using a different frequency. So the selection of the frequency is random. So that's why it's called frequency hopping. And the advantage of frequency hopping spectrum is its robustness against interference. In addition, we also have this feature called header repetition. So the header of the packet can be repeated once, twice, or 3 times. The further enhance the robustness of the transmission. So that's the difference compared to LoRa. LoRa is called chirp spread spectrum. So these two are complete different modulation technologies.
Okay, and then when we talk about announcing the support for it, then how does that work? Can we expect, can customers who are used to using LoRa expect to be able to connect via satellites that are forming a network around the world? How is that likely to work?
Yeah, so the LRFHSS will be supported on 3 of Semtech's existing transceiver chips, SX1261, SX1262, and LR1110. So these devices are already on the market. We will be able to provide a software update. So with the new software that's supporting the new LRFHSS based on the LoRaWAN spec, the new LoRa Alliance spec, and it will be able to transmitting LRFHSS signal.
Okay, and is the infrastructure there? Do we have the satellites that are already supporting this long-range frequency hopping spread spectrum technology? It's not one that I know about well, so I don't know about the infrastructure that's there and available to use at the moment.
Yes, so we are working with multiple satellite companies on the LRFHSS technology, and one satellite company already has a satellite in space that utilize this technology already.
Okay. Do you happen to know where that is?
Where?
Yeah. Geographically.
Geographically, is the satellite is a LEO satellite.
Okay.
So it's rotating around the Earth.
So it's
multiple times
around.
a day. Yeah.
Okay, gotcha. So next question, which LRFHSS, sorry, can you tell me why LRFHSS is a good choice for enabling that direct link from the end device to satellites?
Yes, so LRFHSS has a lot of features that it's ideally suited for the direct link to satellite. So one is the long range. Obviously, it's a long range. It can reach the satellite, and also low power. So it has comparable power consumption to LoRa.
Okay.
So the battery can last, between 5 to 10 years. And also, it has much big capacity compared to LoRa. So let me give you an example. So if you use LoRa lowest data rate, which is called SF12, which is around 250 bits per second, with LRFHSS. So LRFHSS data rate, it's 162 bits per second or 325 bits per second. So it's comparable to the SF12 LoRa data rate. So LRFHSS capacity is about 200 times of the LoRa SF12 capacity. So that means this is very, very important. So when a satellite company launches a satellite, it's very expensive. So every satellite company wants their satellite to connect to as many nodes as possible to have a good return on investment. So with LRFHSS, we can send millions of uplinks per day to a satellite, millions of uplinks per day. So that's, as I mentioned, 200 times the capacity of LoRa lowest data rate. Yeah.
And that's 200 times the bandwidth for data transmission. Have I understood that correctly?
Yes, it's the number of uplinks per day.
But still with the same battery life expectancy.
Yes. So basically, the gateway can process millions of uplinks per day, and then compare to LoRa, so it's about 200 times in terms of capacity. So when a satellite company put a LRFHSS capable gateway into their satellite, so they can connect a lot more end nodes.
Okay, interesting. This is all very interesting about the technology, but obviously the technology is nothing without the use cases. Have you been giving some thought to use cases for satellite IoT, particularly using this LRFHSS technology?
Yeah, so use cases, so the satellite IoT is targeted on remote areas and hard to reach areas. So these areas does not have cellular connection, does not have Wi-Fi connection, may not have LoRa gateways nearby. So for these areas, using satellite IoT is ideal. For example, wildlife tracking, and also smart agriculture to monitor soil conditions, sending soil condition through satellite, and also tracking logistics tracking, tracking goods on land, on sea, and these are the ideal use cases for satellite.
Okay, very good. And do you see it as being a replacement then for the land-based technologies? The examples you gave there were all ones where perhaps there isn't going to be coverage, although LoRa cells can be enormous. But the examples you gave there were for ones that are where there possibly isn't going to be coverage. Do you see it as also being a potentially a competing technology for land-based systems?
No, they are complementary. So LoRa and LRFHSS technology can coexist in the same network. And as I mentioned, the LRFHSS for satellite and cover there's a lot of remote areas that cannot be covered right now by by cellular and by Wi-Fi and by potentially by other wireless technologies. So in these kind of situations, so using satellite is an ideal way to sending these sensor data out. Yeah.
Yeah, that makes some sense. Okay, very good. And anything else that's interesting that's happening in this satellite space at the moment that we should be aware of?
Yeah. So another things need to be aware of with the LRFHSS is a low cost solution. As I mentioned, that it uses our existing LoRa transceiver chips, 1261, 1262, and LR1110. So it provides a very low cost solution for end node sensors to connect to the satellite. And also, a very important point is that um, right now, LRFHS is part of the LoRaWAN specification, and it's a part of the LoRaWAN ecosystem.
Mm-hmm.
So that is a very, very important point. So with a strong ecosystem of LoRaWAN support,
Mm-hmm.
that will really help to accelerate the adoption of LRFHSS
Okay.
in satellite applications. Yeah.
Very good. So you would expect the other members of the LoRa Alliance to be making some quite substantial use of this as a technology.
Yes. Yes.
Okay. Very good. On that note, it's been a very interesting dive into a new technology that I wasn't familiar with, LRFHSS. Tuofu Lu, thank you very much.
Thanks, Matt. Thanks for inviting me.